Hello everyone, and welcome to the solution to the binary search tree check interview problem. Just to reiterate the problem statement, given a binary tree, you had to check whether it was a binary search tree or not. So if we just zoom in here, it's a little too much, so we can take a look at the solution. I'll just be walking through the solution notebook. I won't actually code anything out live because there's quite a bit of code, but actually one of the solutions is really simple. So the simple solution is to know that if a tree is a binary search tree, then traversing the tree in order should lead to the sorted order of the values in the tree. So we can actually perform an in-order traversal and then check whether the node values are sorted or not. So if you go back to tree traversal lecture, you should be able to check out the function we had for the in-order traversal of a tree. So here that is just straight from that lecture. And in this case, what I did was create a list called tree vals, and I appended the values of the tree as we traversed in order, and then went ahead and did a sort check. And what this sort check function does, it takes that list of tree values and then just checks if the tree values list is the same as the sorted version of the tree values list. And so with that function here, I can check if the in-order traversal of the tree actually was the sorted values, and then I know it's a binary search tree. Another classic solution is to keep track of the minimum and maximum values a node can take as you go through the tree. And that each node, you're going to check whether its values between the min and max values it's allowed to take. The root can take any value between negative infinity and positive infinity. At any node, its left child should be smaller than or equal to its own value, and similarly, the right child should be larger than or equal to that own value. So remember, this was the BST property. You can go ahead and review the binary search tree lectures, but this is essentially just checking each node for that BST property. And then, so during recursion, what you're going to do is send the current value as the new max to the left child and send the min as it is without changing it. And to the right child, what you're going to do is send the current value as the new min and send the max without changing it. So here's an example of that sort of logic coded out. So you have this class node here. In this case, we have key, value, and then left and right as none. As I mentioned before, you can use basically any node class you want, something that just makes sense to you, because in an interview setting, they're probably just going to expect you to write out your own methods here. And in this case, I just have the function tree max, tree min, and then I have this verify function, which if I zoom out a bit, you can see it in its full scope. And I just have some examples here. If we go ahead and just go back up here, what's happening here on tree max is if we're saying if not node, just return a float of negative infinity. And what this allows us to do, if I just copy this and go to a try.jupyter, empty cell, this just allows you to have negative infinity in a notebook, or excuse me, in Python. But coming back to this, if it's not a node, that it does not end up being true, you just return negative infinity. And then otherwise you have max left and max right variables, and that's equal to the recursive call on the left and right nodes, and you just return, again, key, max left, max right. And you're doing a similar recursive call here, except it's the minimum now on the left and right of that node. And basically, throughout this verify function, all we're doing is just making sure that BST property is true. So we're making sure that that node left into the tree max function is less than or equal to the node key, and that at the right it's greater than or equal to, and you also verify the node left and node right through recursive calls. Basically just keep recursively verifying each node in that fashion. So to give an example of what this would look like, we have 10, 5, and 30. So 5 is less than 10 and 30 is greater than 10, since they're the left and right nodes respectively. So that will print true since that's correct. Here we have 10 as our root. The right of that is 20, so that's still good. Left of that is 5, so that's still good. But what happens is we have left right equal to 15, and since 15 isn't in the correct position, it's going to print false, since 15 is to the left of 10, and it shouldn't have been on the right there. Okay, so you can go ahead and check out this code yourself, and go ahead and put in examples here into this node code, so you can understand what verify is doing and these recursive calls on the min and max checks. But really, the key to understanding this problem in the second portion is going to be the BST check. And really, in an interview setting, you're most likely probably going to be asked to implement this solution instead of the sorting trick here about the in-order traversal. Okay, with that being said, definitely review this one because it's a classic interview problem. Feel free to just Google search validate BST in case you want more information on this problem as well. Okay, thanks, and I'll see you at the next lecture.